going to do a quick test today of a Comtech KU band LPOD BUC. Originally I was going to do this demonstrating how I could use a 70 megahertz modem and a Comtech frequency converter. Unfortunately I've run out of time. This has to be packed and shipped today, and so I'm going to use instead my Comtech EFData 570L L-band modem. A couple of things that I've had to do on this modem. The first thing is that this Comtech BUC does not require 24 volt or 48 volt over the IF cable, and so I've disabled that. Also, this BUC doesn't need 10 megahertz reference, so I've disabled that as well. It's a very complete BUC. It takes its power from the AC, not from the IFL cable. So if you look at these three connectors on the side, to the left, J1 is the transmit in. That's coming from the modem. That's going to be an L-band signal from that Comtech EFData 570L modem. The J3 is the power cable connected directly to my AC, and to the right is an M&C cable. This is one thing that I can't use today because this is a brand new BUC. Well, I say brand new, it doesn't look as if it's ever been used, because the original connectors are still in the box with it, and I haven't had time to make up the M&C cable. But fortunately this BUC is enabled to transmit without having to make any changes over the M&C. So although I can't demonstrate all of the features that Comtech would offer, I can at least run through the frequency range of 13.75 to 14.5 and make sure that the BUC is transmitting correctly, just using the modem as the control. The other item attached to the BUC is this combination of cross-guide coupler and dummy load. The dummy load prevents any radiation straying into the room and frying anything, including me. The cross-guide coupler with the cables hanging off it allow me to connect to a spectrum analyzer to check the frequency, and that gray blocky thing is the power head that connects directly to the Agilent power meter. So those are the two items that I'm going to use to measure the output. Below is the Agilent spectrum analyzer, and the top is the power meter. There's another connection on the side of this BUC. If I was not using this cross-guide coupler, I could connect directly to that silver port. The silver port is an attenuated output measuring port, and you can see from the label that it's attenuated to minus 40.8 at 13.750 and up to minus 40.8 at 14.5. So that also shows the total output range of this BUC. It's the complete KU band frequency. Let's just verify the settings on the modem. First I'm going to go to the ODU. I know that I've made these changes already, so it's not going to be a surprise, but at least I can show you where they're made. Going first to the BUC, I'm going to look at the 10 megahertz reference. 10 megahertz reference is off. What I want. Going to go to the local oscillator. Local oscillator frequency is 12.8, which is correct for this BUC. It's not necessary to do this, but what it does, when I set the frequency on this modem, it automatically translates it to the KU band frequency. For example, if I set 1000 megahertz in this modem, that's the L-band frequency, it will come out as 13.8 gigahertz in the KU band range. So as I say, it's not necessary, but it just makes it easy when you're setting the frequency to see what the KU band frequency is going to be when you set the L band frequency. It sounds a little bit convoluted, but that's what it's all about. Okay, and now let's go back and look at the DC power. DC power again is off. So verifying once more that I'm not sending any 24 volt or 48 volt to this BUC. This BUC is relying entirely upon the AC power supply. Okay, now let's look at the transmit and see where the frequency is. The frequency is 1000 megahertz, as I said, 13.8 in the KU band range. So I'm going to get the BUC set up, turned on, and we can begin the test. Oh, now as it's come up, I'm at 14.5, top end of the frequency range, and based on the power is negative 37. I'm showing 7 watts. I want to bring it up and see where it settles at 14.5. I won't take it really much above 100 because that's the most because 100 watts is the maximum usable power in KU band. So I'm going to increase. By increasing, you see this goes down because this is attenuation. 8 watts. Increase by a couple more to negative 34 with 13 watts. Let me step this up so it doesn't take forever to get through this. Neg 28. Okay, now we're up to 48 watts, basically half the power. But now I have to be a little bit more cautious. Neg 27, and we're showing 84. I'll take it to neg 28. Sorry, I really went the other way. I'll take it to neg 26. Okay, it's 102 watts. I'm not going to take it beyond that. But what I want to do now, I want to change the frequency. So we know at 14.5 it will put out 102 watts at negative 26 coming out of the modem. So now let's go and change the frequency. I'm going to change the frequency to 14.0 this time. There it is, see on the bottom level, 14.0. Of course it disappears off the spectrum analyzer because I'd have to reset the spectrum analyzer to see that. But what is interesting is that the power has now dropped to 94. And don't forget, I haven't changed the power settings. And so the output power is just a function of the frequency and the design characteristics for this particular buck. So now we're going to go down even more. I'm going to see what it looks like at 13,750. 13,750 is the bottom of its power range. There it is, 13,750. I'll make the change and watch and see what the power changes to on the power meter. Dropped even more, it dropped to 86. So when we're running this in real life, we would probably have to adjust the power as we adjust the frequency. Not that the frequency gets adjusted very, very often. And typically when you're using these, you know the frequency that's been assigned to you by the satellite operator, and all you have to do is to adjust the power to a suitable setting, normally defined by the operator. So what I'm going to do now, at 86, I'm going to increase my power a little bit and get us back up. See, it's coming up. There, just by increasing the power, we've come back up to 107 watts. So that's in the PSAT range, not in the P1 dB range. This is 13,750. Let me just adjust the spectrum analyzer so we can see it. There it is. So it's outputting okay, and it's outputting at 107 watts now. So for a very simple test of this 125 watt KU band buck, we've seen that it works very well across the entire frequency range of 13.75 to 14.5. So now I have to wrap up the tests because we have to wrap up the amplifier. It's been sold. It now needs to be packed carefully and shipped to the new customer. So thank you for watching.